Alright, so what you just saw was a keyboard made entirely in Desmos graphing calculator. Shout out to this person, I'll put them on screen right now. They said I should do something with music, so I procrastinated doing my homework and just whipped this together in 10 minutes. And you guys saw the final result. What I'm going to do here is just go through a quick tutorial on how you can make something like this. Alright, so to start out, we need to look at the tone function in Desmos. We have tone, see that the text gets unitalicized. That means Desmos no longer thinks it's a variable and recognizes that it's a function. So we know to be able to do something like this, you should know how to work with hertz. So you should know that 440 hertz is orchestra A. So you can click on this thing here to turn on and off the sound, just like you would click on it to hide and show a graph. So we have tone 440, and hertz aren't linear, they are logarithmic. So one octave up, the next A is 880 hertz. Okay, so let's make a function that allows us to take a number 1 through 13 and convert it to a note on the chromatic scale. 1 being A, 13 being the A one octave higher. So we have 2 points so far. The first A is 440 hertz. That's a point 1, 440. The next A is 13, 880 hertz, because remember, it's an octave higher. So we have these 2 points. Now we can make an exponential function. So we know that the rate to the 12th equals 2. So that means that the rate equals 2 to the 1/12. There we go. So now we have this. The base is 440 times 2 to the 1/12 to the power of x, which is 2 to the x over 2. This right here is our function. So we can set that as f of x. There we go. So now we have a function that converts a number to a frequency. For example, let's do tone f of 1. This should be an A. Let's try tone f of 13. This should be an A, 1 octave higher. There we go. So let's make a variable that will control the key. Let's call it A. Actually, no, let's do A. So let me turn this off. Let's change the constraints of the slider 1 to 13, step 1. So now we have a chromatic scale in the key of A, and you can listen to it here. All right, so this is a great start. Now we can set A to a value, and then it will play a sound of that value. This is essentially all we need, and then we can add more stuff, but let me go more in depth on what we're going to be doing with this. So our keyboard is going to be just a chromatic C scale. So it'll start at middle C or C4 and go up to C5. Well, we have a problem here. Our range of A starts at 1 and goes to 13. This is an easy fix. If this goes in a chromatic scale and A is 1, then C is simply 4, because C is 4 half steps, is 3 half steps over A. And then we do the same with the max. We just add 3, 16. And now we have C4 and C5 as 4 and 16. Let's test those out. All right, great. So we're going to do this using polygons, and we're going to have the keys going, each of them being 1 wide. So one, you can, you look at the outlines here. 1 here, here. I'm just going to do the white keys for now. Here, 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 and here. So let's make a function. Let's make a function. Polygon don't make it the actual polygon function. Polygon, and to do these little underscore things, on Mac, press Shift minus, or it's just the underscore key. So polygon of, let's take 3 inputs, X position, height, X position, height, and width. Or let's do X, width, and height. That order makes more sense. Equals polygon, and then okay, so now what we're going to do is write a function for a polygon with X position, the center of it, at value X, width, value width, and H units high. So this shouldn't be too bad. First, let's imagine we're plotting polygon -4, 1, 3. Let's -3.5, because then it'll be centered here, and it'll be this wide since it's 1. It'll be this tall. So we can use that as a reference. The X value of this first point will be X minus width over 2. The Y value will just make the top of the keys 1. So let's make that a point. And the next point is X plus W over 2, comma 1. Okay, now we're going to go, now we have this point and this point. Now we need to go down to here. So we're going to keep the X value the same, X plus W over 2, and then the Y value is 1 minus H. There we go. All right. Sorry about that. I had written this wrong. And then finally, X minus width over 2, comma, comma, 1 minus H. There we go. Now that's literally all it is. So now we have this key. This should be C4. Now let's paste the exact same thing, but move the X value up 1. Let's do this until we go through all the keys. Oh. Great. So now we have this. Bum, 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 bum. Of course, it doesn't make sound yet. We can get that done later. Now let's make the accidentals. So those are the black keys. At least they would be black on a regular piano. So again, let's start with this one. The center looks like it should be -3. All right, the width, let's make these 0.5 width. 0.5, and then the height, let's do 2. See how that looks. That looks pretty good. We can do this for all the black keys. Oop, that does not exist. There we go. All right, now we have the layout. We can make this look cool later. And now we need to make it work. Now we have the tone function, and we have all of the polygons. Now we just need to put them all together. So let's start with this. Let's turn on clickable. So this is clickable. On click, since this is C, A, goes to 1. Right, so whenever this is clicked, sorry, not 1, 4, because 4 is C. So whenever this is clicked, the A value is automatically set to 4. Let's test this with the sound on. And now let's click this. There we go. Works great. Now this next one, this seems like it would be a common mistake. This is not A equals 5, because this note is in between. So it's 4, 5, 6. A goes to 6. And then 6, 7, 8. A to 8. 9. Clickable, turn on A to 9. And then you just count for every single one. 9, 10, 11. You scroll down. A to 11. 12, 13. Oops. A 15. And then finally A to 16. All right, so let's test this out. Let's turn on the sound. And let's start playing these white keys. These aren't activated yet, but we have these set up. All right, so now let's just add these black keys. Make this clickable. I'll click negative A goes to 2 because, or not 2, sorry. Remember it starts at 4. A goes to 5. A goes to 7. A goes to 10. A goes to 13, or not, can't count, 12. A goes to 14. Congratulations, you have now made a working keyboard in Desmos. Let's try this out one final time. All right, here's one final thing. You're saying, well, this doesn't look like what I saw in the preview. This doesn't look like a piano. Do you want to add color? So the blank keys are easy. We already have black in Desmos. Change the color to black. And if you want, change fill to 1. So black, 1, black, 1, black, 1, black, 1. Oops, black. There we go. And then for these, you'll see there is no white, so we'll have to add it. If you already know how to add colors in Desmos, if you don't, this is how you do it. W underscore white. You can name it whatever you want. You can name it like, it works either way. I'm going to call it white just for simplicity. Equals, and oops, equals an RGB value, and the RGB value of white is 255, 255, 255. You can see it pops up down here. And now we can just change all of these to white and fill 1, white, 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 fill 1, and white, fill 1. Well, you're probably noticing something is not right about this. It sure still works. It works, but you can't really see the keys. And that is because now that we've made them solid white, you can't see the border because you just can't see the borders. So we are going to have to make our own. That is very easy though. We just have y equals 1, that line on the top right there. You can add some constraints. Absolute value of x is less than 4 or equal to. Even though it makes no difference, I just think it's cooler. We can do the same for the bottom, but y equals negative 2. You make both of these black. Oh, well, you can't see them because they're behind these. Let's bring them to the front. And then finally, we can use a list to set the x values. So x equals all of the points, negative 4, ... 4. Then we can set the constraints as negative 2 is less than y is less than 1. Oops, forgot to end off my list. And boom, there you have it. This is a piano in Desmos. And let's give it one last try now that it looks cool.